Welcome back, guys. So today we're going to revise lesson 2, so looking at how elements are arranged in the periodic table. So you might have wondered how Mendeleev knew where to place each element when he was designing the periodic table. You might have also wondered why each element is where it is on the periodic table, and we are going to look at this question in more detail, and hopefully by the end be able to answer it independently. So elements are grouped together basically according to the similarities in their properties. And examples of properties, we've looked at properties before, but for example, it could be because of their melting points, their boiling points, their density, so the mass of size. And so the periodic table is arranged because of those properties, and similar elements are grouped together. So we're going to look at groups, and we're also going to have a look at periods in more detail. I think for this to look at this lesson, what I will do is go back to the page with the periodic table because it's a lot bigger, and I can explain it in more detail. So we have groups. So the groups are the numbers that you see at the top. So this column is group 1. So everything in this column is group 1. Everything in this column is group 2. Everything in this column is group 3. This is group 4. This is group 5. This is group 6. Sorry, I'm just going to finish those off. And this is group 7. And this is group 0. But why? Why are those elements in group 1? Why are those elements in group 2? Why are those elements in group 3 and 4 and 5 and 6, etc., etc.? And this lesson explains why. And I'm going to explain it to you really quickly as best as I can. So, for example, if I have a look at group 1 and I take lithium as an example. So lithium, if you remember when we were looking back at our year 7 content in our previous video, lithium atoms will have a nucleus in the middle with our positive protons and our neutrons, which I'm just going to write as 0 because they have no charge. And then around it, we would have a shell, and the first shell will have 2 electrons. And then, if you remember, I said that the second shell can hold a maximum of 8 electrons. But because lithium is in group 1, it only has 1 electron on its outer shell. And the electrons, I'm just going to write like this. Sorry, that's a really bad drawing. That's supposed to be lithium. So this is what the atom of lithium would look like. And in sodium, again, the outer electron, the outer shell, of sodium will have 1 electron. The outer electron of potassium will have 1 electron. The outer electron of rubidium, etc., etc. So all the elements in group 1 will have 1 electron on the outer shell. And what I think might be useful, just until you understand the concept of this, is under group 1, or under where it says 1 on your periodic table, you can just write 1 electron on outer shell. So feel free to make a note of that in where your periodic table is to help you remember it. And then having a look at group 2 in a similar way. Group 2 elements will have 2 electrons on their outer shell. So if we take beryllium for an example, Be, again, it's going to have the nucleus with the positive protons and neutrons. It's going to have one shell with 2 electrons, and then the second shell around that is going to have 2 electrons. The extra 2 can be placed anywhere, it doesn't really matter. So it's going to have 2 electrons on the outer shell, and that is what the atom will look like. So here again, you can make a note: 2 electrons on outer shell. Sorry, my writing's really bad, but it's just hard to write on the computer. Hopefully you can understand that. Again, and then similarly, I mean, in group 3, they're going to have 3 electrons on the outer shell. So if I take boron's going to have an extra one, and then group 4, carbon, is going to have an extra one, and then if I do oxygen, it's going to have 6 on the outer shell. Sorry, I forgot group 5. So group 5, for example, nitrogen, it's going to have 5 on the outer shell. And if I take oxygen, oxygen is going to have 6 on the outer shell. Fluorine is going to have 7. And neon is going to have 8. And hopefully that drawing helped you out a bit and helped you understand it a little bit better. So very simply, the group the element it's in is telling us how many electrons are on the outer shell. So group 3 will have 3 electrons on the outer shell. Group 4 is going to have 4 electrons, etc., etc. And that is what the group number is telling us. The next thing they mentioned in the lesson were the periods. So I'm going to explain that in more detail. So for periods, we're having a look at, and I'm going to write the number on the periodic table, and you can annotate it on your own periodic table as I'm doing it. But basically, periods are describing the pattern as we go down a group. So what would help is if you write 1, 2, 3, 4, 5, 6, 7 along the side. The 1 is just matching with the hydrogen. So lithium and beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon are in period 2. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon are in period 3, and these are in period 4, 5, 6, 7, so on. So we have groups along and periods as we go down. So let me just make that a little bit neater. So as we go along, mess that up again. So as we go along, we have our groups, and as we go down, we have our periods. And I'm going to explain to you what they mean in just a moment. So the period number is telling us how many shells an element has. So lithium will have 2 shells, sodium will have 3, potassium will have 4, rubidium will have 5, cesium will have 6, and francium will have 7. So do you remember again when I looked at the recap for our year 7 stuff, I said to you that atoms can have a number of shells? The period number will tell us how many shells it has. So hydrogen just has 1 shell. Lithium will have 2, so it will have 1, 2. Sodium will have 3, so 1, 2, 3. And potassium will have 4. But because they're all in the same group, remember, they all have the same number of electrons on their outer shell. So they're still going to have only 1 electron in that outer shell. because they're in group 1, but the period number is just showing us the number of shells they have. And basically that is all that this lesson compiles of. I'm just going to go back to see if I missed anything off. So let's have a look. So as you go in columns, so the columns will represent the groups, the changing groups, but as we go horizontally, it's showing us the period. So period 2, 3, 4, 5, 6, and 7. And then you just have your activity questions, which you should have marked already. But that is just summarizing that lesson for you. Hopefully that helped. Stay tuned for lesson 3.